Alright, so we're doing polynomial operations. Last time we did, figuring out what the name of it was. We're naming it by name, naming it by other different things. So this time we're going to kind of change gears a little bit for this one. And again, this is not really anything new on this part, but basically we've got three different operations we're going to do. First thing is we're going to either add or subtract, which when we add or subtract polynomials, again, we're going to combine like terms. Okay, and the big thing is when you're adding and subtracting on these, the big thing you got to remember is that your powers don't change. The only thing that's going to change is the coefficient that's in front of the number or the numbers that's in front of it for these. Okay, so if we're doing 3x squared plus 11x plus 4, and then adding that to negative 5x squared plus x minus 13. Okay, and I'm going to go highlighters just because it's easier to kind of, see everything and what's going on with it so we can kind of match up. So again, adding, subtracting, all you're doing is you're just combining the like terms as you go through these. And for this part of it, the like terms you have for this one, again, that's everything that's got the same power. So basically everything that's got the same degree. So this one's x squared, so these two would be the same. We've got 11x and the x that's here. So those two would be like terms. And then on the end, we've got the plus 4 and then the minus 13. Okay, so if you separate everything out by that part of it, we've got the 3x squared and then the negative 5x squared. Okay, and then we've got the plus 11x and then the plus x. And again, remember, when you're doing this, when you're adding those, there is an understood 1 that would go there. So technically we're doing 11x plus 1x. And then on the last one, we've got a plus 4 and a minus 13. Okay, so separate everything out to figure out what your like terms are. And again, like terms are just anything that's got the same power. So now we've got 3 minus 5, so that part would be negative 2 x squared. And again, we're doing these. The powers don't change. It's only the numbers in front, which is the coefficients. That's the numbers that change. 11x plus 1x, that would be a plus 12x. And at the end, 4 minus 13 would be a negative 9. Okay, so that would be the answer that we're looking for. And some of the problems that you may run across, there may be, some other little things that where they add to it. It may be, instead of just being 3x squared, it might be, and you don't necessarily have to put this in here, but just kind of watch. It may be that that term is 3x squared y. If you do that, that still doesn't change anything with the answer, other than that there would be an extra y that would be on the end of it there. For something like that. So again, it's always got to be the same thing, that if this one's x squared and y to the first, you need another one that's got x squared and y to the first. Okay. So again, the variables can be all kinds of different things. You're just looking for the ones that have the same variables with the same powers, and that's what you add or subtract. With subtraction, again, it's not that it's hard. You just have to be careful with subtraction. Because before you can really do anything, you've got to do one extra step. All right, so if you had a subtraction problem, you'll have something that would look something like that. Okay, and before you do anything on the subtraction one, the first part is okay. So you've got the y squared plus 4y minus 3. That one's good. So before you do anything at all, though, with subtraction, just go back and change all these signs, because that's what subtraction means. You've got to change everything. So that's going to be a -1. That's going to be a +2. That's going to be a +5. And that would be a negative y to the third. Okay, and then once you've changed all the signs out of subtraction, now it basically becomes an addition problem. So now you're looking for everything that's got like terms. You've got a y squared here and a y squared here. You've got a 4y here and a 5y here. And then the other part, and these two are actually kind of gathered here, you've got the -3 and then the -1. The negative y to the third, there's no other power that's there. Question? Oh, if it's subtraction, that basically, if it's subtraction, it's like, basically what it is, you've got like a -1 that's here, and you're doing -1, you're doing distributive properties. You're doing -1 times this, -1 times this, -1 times that, and then -1 times that. So basically anything with subtraction is you're just going to change all the signs in the parentheses behind it. Okay. And again, addition, you don't have to do that. It's just the subtraction ones where you have to worry about that part. Okay, so change all the signs. Now you're basically back to just making an addition problem. So now we've got the, and again, technically you've got a 1 that's here, so that's 1y squared plus 2y squared. This next step, if you, again, just kind of color coding it so we've got everything back together. We've got the +4 and the +5. Oh, just going back to kind of color coding everything. So, oh, the y squared that was here, there's not a number in front, so we just put a 1 there. Okay. For the -3, -1, again, it was already together, but we'll just go ahead and rewrite it that way. And then minus y to the third. Okay, so once you've got them, everything kind of grouped together, then again, you're just adding and subtracting. Now it's 1 plus 2, which is 3, y squared. You've got 4 plus 5, which would be a 9y. -3, -1 would be -4. Now, and probably most of these, they're going to ask you to write the answer in standard form. So if they ask you to write the answer in standard form like we were doing on the other day with these, that negative y to the third would actually need to be first. So instead of putting it at the end down here, we're going to put it there. And this was a +3, so we put a plus there. Okay, if they don't say anything about standard form, then you can just drop that negative y to the third and put it here. But again, if they talk about something being standard form, you would start with your highest power, and then you work your way down. So we got y to the third, y to the second, y to the first, and then no y's on that one. Sorry, a little crooked there. All right. So for the next thing, we've got multiplying polynomials. And again, we've already kind of done this one, but just backing up to make sure everybody remembers what to do. Basically two things. You're going to multiply the coefficients. And remember, coefficients, that's just the numbers that's in front of x or y or whatever variables they give to you. That's your big numbers. And then you're going to add the exponents. Of the same variables. Okay, so you multiply the big numbers and you add the exponents, which is your little numbers. Again, variable is just your letters. Okay, and again, we've already done this a little bit, but most of the time distributed property, when we did it, we were just multiplying by a number. We did a little bit with the full method where we had to do some of that, but this was going to be just a little bit more, one more extra step past that one from the things that we had been doing. Okay, so for this one, just distributed property. So we're doing 2 times 3, 2 times 4, 2 times 2. All right, and again, you're going to multiply your coefficients. Well, again, that's the big numbers that's in front of x, or in this case, m. And then you're going to add your exponents. So we're going to do 2 times 3 to get 6. For the m's, you've got 2 plus 2. So that's 6m to the 4th. We're doing 2 times negative 4, which is negative 8. Again, technically there is one m there, so it's m to the 1st. You've got 2 plus 1, so make it m to the 3rd. And this one you've got 2 times 2, so 4. There's no other m's here, so that one's just going to stay m squared. Okay, so distributed property is pretty straightforward. We'll do another one with doing some full method, because that's some of the ones that we've done more of. I guess really we did reverse full method when we were doing all the factoring. We were kind of going reverse full, so this time we'll take it out here. All right, so let's do this. Let's do 2x squared plus 5y times 3x minus 4y. Okay, so top part, we'll do 2x squared times both of these. So we've got 2x squared times 3, so 2 times 3 is 6. Again, you've got x to the 1st and x squared, so it'd be x to the 3rd. Then we've got 2 times negative 4, which would be negative 8. You've got 2 x's and 1 y, and those will stay separate because, again, if it's different letters, they won't. You can put them together, but you don't do anything as far as changing the exponents or anything. So if it's x squared times y, it just stays x squared times y. Okay, on the bottom side, we've got a plus 5 times 3, so it's 15 xy. Yeah, so 8x squared and then y. Yep. Okay, 5. And again, whether you put x first or y first, it doesn't matter. Most time people just put it in alphabetical order. So if you've got a and b, most people put a first. There's no really right or wrong way when you're doing those. 5 times 4 is negative 20. And then y to the 1st times y to the 1st, so you've got 2 y's. So it'll be y squared. Okay, now, and a lot of times you'll get, usually if you do this, you get some terms you can add or subtract, but this one, we've only got x to the 3rd. This one's x squared. This one's only x to the 1st, so you cannot combine these two together. That one's y squared, and there's no other y squareds. So for that one, that would just be your final answer. So sometimes you can combine some like terms. Sometimes you're not able to. It just kind of depends on the problem, which one we're doing. All right, I'm going to show you one more multiplication. Okay, if you happen to get 3 different numbers or 3 different expressions, you got to multiply. Because now we're doing the full method with these two, and some people are like, what do we do with the 3rd one? Well, we'll basically do another full method on this one, but we'll kind of get you there first. So, Okay, so before we get to the last one, before we get to the x plus 4 here, just forget about that, cover it up for a minute, and just pretend like we're doing x plus 5 times x minus 2. So don't even worry about the x plus 4 that's back here. Just, forget about it. Just cover that up for a minute just so we don't see it. Okay, so we've got x times x, and then x times negative 2. So if you do x to the first power times x to the first power, you get x to the second power. When you do x times negative 2, it's just that. It's just negative 2x. Okay, and with the 5, you've got 5 times x, so that's plus 5x. You've got 5 times negative 2, so that would be negative 10. Okay, and then in the middle, you've got these two numbers you can put together. And a lot of times that's what's going to happen when you're doing these. That usually you've got at least a couple of terms that you can kind of simplify. So we've got x squared. This one is 5 minus 2. So that's 3. And then minus 10. Okay, so if we only had those two parentheses to multiply together, that would be the answer we had. And again, that's just doing, like when we're doing factoring, this is just reverse factoring, if you want to think about it that way. Okay, but you've got this extra x plus 4. Okay, now some people still want to go ahead and do distributive property on this one, and that's fine. I may show you like a couple of ways you can do this one. So we'll do like one version over here, and then we're gonna do another version over here, just so you can kind of see what happens with it. If you don't like the second version, don't worry about it. You don't have to do it. Just gonna show it to you. Okay, so now we're gonna do x times x squared, x times this, and x times that. Question? Sure. And the good thing when multiplying just by x is that you just bump up all the powers. This one had 2, now it's got 3. This one had 1, now it's got 2. This one didn't have any, now it's got 1. Okay, and then we'll do the same thing with the 4. But now here's where you want to kind of save yourself a little bit of work. Instead of just putting these on the end of it down here, here's where we're going to try to make work a little bit easier. If you do 4 times x squared, you can put the 4x squared here. But since you've already got an x squared term here, just put it right underneath it. Because we're going to move stuff around in a little bit anyway to get the like terms together. So we've got 4 times 3x, which would be 12x. And then 4 times negative 10 would be negative 40. Okay, and then that way now everything's kind of stacked up. You've got just an x to the third, so that would be it. This one's 3 plus 4, so that's 7. This one's negative 10 plus 12, or 12 minus 10. That's a positive 2. And then there's no other number here, so that's just a negative 40. Okay, so if you happen to get one where you've got to multiply, 2, 3 parentheses, if you got to do 3 parentheses instead of 2, it's not a whole lot of work to save on those, but it does save you a little bit of work when you're going through these. Okay, now you don't have to do it that way. Some people are like, what if I don't do it that way? What if I just, keep writing these numbers out at the end, and then I rearrange it, like we did back here with these? That's fine. This is one, though, I'm just trying to save you a little bit of work. If you happen to get one of those that, you can kind of make it go a little bit quicker, so hopefully it looks a little bit neater as you go through that. Okay. All right, so adding, subtracting, multiplying, that's the only three. We're not doing any division on these. We'll just get those three. The other thing we got to look at today, it's factoring, but it's one of those where it's like I hate to say it's a special case factory. factoring, but it's one of those special cases where when you see it, you'll kind of you'll know what it is because there's only one really way that you can kind of look at this one. So, okay, everybody get there? Anybody still? Oh, and I didn't show you this one. And again, you don't have to write this down, but some people may not like this at all. But I'm just going to show it to you real quick. That if you got something like this, where you've got like these three things here, and you got something that's a weird looking full method. Instead of writing it out that way, we're going to write like an old multiplication problem. Again, you may look at this and go, I don't like that. If you don't like it, don't worry about it. You don't have to. If we do this one like an old multiplication problem, you're going to take 4 and you're going to multiply it by all the numbers up here. So you got 4 times 10 for negative 40. 4 times 3x for 12x. 4 times x squared would be 4x squared. Okay, and then you would do the same thing with x. You would do x times this number, x times this number, and x times that number. And when you do x times negative 10, that's negative 10x. And if y'all remember, like when you did the old multiplication, how you kind of put a space holder, this one, same thing. You got a space holder that's here. So when you do x times negative 10, you got to start it right there. X times 3x would be 3x squared, and then x times x would be x to the third. And that way, you've still got the exact same things. It's just a little different order. We've got the bigger numbers on bottom, the smaller exponents on top, but when you put it together, you still get the exact same answer that you've got there. And some people look at that and they're like, no, I don't like that at all. I'm like, okay, if you don't like that, then you can just forget about it. You don't have to worry about it. If you know, drawing out your arrows over here where you've got a bunch of loops and rainbows and hoops and whatever you got for that part, if that makes more sense doing it that way, then stick with it that way. But this is just a different way you can kind of look at it too. Okay, and then the last thing we've got for today, we're going to do, again, it's a special kind of factoring thing that we've got here. Bless you. That we're going to be factoring the sum, well, not and, or the difference of cubes. Okay, and this is one where, again, you definitely want to kind of have this one, when we do the test on this one, it's definitely going to be, you just need to know the formula for it. So this is one of those where it's really going to come in handy that y'all got this and you can write it down because everything is based off this one little formula that's here. And it's just kind of I hate to say it's kind of a weird thing, but it's kind of sort of a weird thing where that we're not really going to do just a whole lot with it when it comes off everything that's here. All right, so basically, here's what we've got. Let's say that we've got something like this. That let's say you've got, and they always start off with A's and B's on this one, and we'll actually give you like actual numbers with it here in just a minute. But let's say you've got A cubed, and again, if we're going to do sum, we're going to do plus B cubed. So we got something cubed plus something cubed is what it comes off of. Okay, and here's your formula. Here's all you got to know. That the answer is just going to be A plus B. So if this thing starts off with A cubed plus B cubed, you would start off with that one. We're going to do A squared here, B squared here, and in the middle, we're going to put a minus, and we're going to do A times B. Okay, and then one more underneath it. So that's the one for sum. Show you the one for difference. Because it's almost exactly the same thing. Okay, this one was A plus B. This one was A plus B. Your first parenthesis is going to be the same thing. This one's going to be A minus B. We're still going to have a squared here, still going to have b squared here. Still going to have a plus there. You're still going to have an ab here, but that one's going to be a plus. Okay, so two formulas. The only thing that's different between the two, and it's not a big difference, is really where the minus sign is. Depending on how this thing is written and where you put it, then basically you just swap this minus sign here and this plus sign here. Everything else is exactly the same. And again, the good news is that when y'all take the test, you've got this that you can have in your notes. So as long as you got your notes, you know, you're good to go. You don't have to worry about anything. Okay, now, and the thing is when you're doing these, there's not, some people are like, well, what do you do when you get the answer? I'm like, this is it. We'll show you a problem, and once you plug it into this little bit of formula, that's the answer. The only bad thing is back here, you got to do a little bit of work back here with some of this, but for the most part, it's just here it is, and you plug it in, and that's all you do. So they'll say the factor, and you'll have something like x to the third plus 8. Or they may say, like, find the sum or the difference of the cubes. Either way, it's still the same thing. Find it, factor it, whatever you want to call it, same thing. Okay, so this one, pretty straightforward, because this, instead of a to the third, we've got x to the third. This number, though, is not to the third power, so all you've got to do is figure out, all right, if I've got 8, then basically it's got to be something to the third power, and you got to figure out what that number is. And the numbers are all going to be pretty quick if you go back and do that one. If you start multiplying, now obviously it's not 1. If it was 1 times 1 times 1, it would be 1. But if you check 2 times 2 times 2, that would be 8. So to make this thing fit into the formula up here, where we've got a, that's going to be x. Where we've got b, that's going to be a 2. Okay. And that's pretty much all we're going to do is that, again, everywhere we've got an x up down here, we're going to put an a in place of that x, or x in place of the a there. Okay, so we're starting off with a plus b, which means it's x plus 2. Instead of a squared, we're doing x squared. Instead of b squared, we're doing 2 squared. And then this thing is minus. Technically, it's x times 2, but let's just reverse that around and make it 2 times x. Okay, and pretty much the only thing you have to fix is if you've got this number squared. Oh, it's positive. I forgot that. Just go ahead and do 2 squared and make it 4. And most people go, well, what else do you do to it? That's it. That's all you do. So it's just taking out these two numbers, and everywhere up here where you've got an a or a b, you're just replacing a or b with x or 2 or y or 3 or whatever the numbers happen to be, or letters. You're just replacing those things out, and that's all you do. Once you've plugged that in, the only work really is that you've got to square this number, and that's it. That's all you do. And most people are like, what do you mean that's all you do? That's all you do. There's nothing else really that you do with this one. Question? Hold on just a minute. We'll all right, let me show you another one here with the difference. Okay, so maybe they do this one. Instead of saying factor it, they may just say find the difference of, and then you got y to the third minus 27. Okay, so again, we know that's cubed, so we're good there. But the 27, we got to figure out what that is as something to the third power. And again, if you just run through your numbers real quick and just do the third powers, that's going to be 3 to the third power. Okay. and again, you don't have to write this, but I'm just going to write it underneath here. So because the formula that's up here, I'm going to just write it real quick. So the formula was a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. Okay, and again, the only difference is now we're replacing a with y and we're replacing b with 3. So that means this is going to be y minus 3. Instead of a squared, now it's y squared. Plus 3 times y, or y times 3, but I'm going to go ahead and put 3y just so we've got it there. Then plus 3 squared. Again, really the only math you have to do for that particular formula is on that last number. Go ahead and do 3 squared and make it 9.